Hello, and a very good morning, good afternoon, and good evening to all our viewers from around the world. And welcome to this webinar brought to you by the Institute of Marine Engineering, Science and Technology, Houston Gulf Coast branch. I'm Rajneesh Kelkar, the Vice Chair of the Institute's Houston branch, and today we have a very distinguished speaker with us. We have Dr. Bhadir Inozu, who is the CEO and co-founder of Sharp Focus Incorporated, and he'll be presenting today's webinar titled Using Artificial Intelligence Technologies for Dynamic Risk Management. Dr. Inozu was a professor at the University of New Orleans from 1990 to 2006, and during that time focused on applied research for reliability management of marine systems. From 2001 to 2006, he also served as the chairman of the School of Naval Architecture and Marine Engineering. Presently, he is the professor emeritus teaching at their engineering management program. Dr. Inozu is also an adjunct professor at the Bovard College of the University of Southern California, where he teaches project management courses. He is also an author and a co-author of a number of books and has published articles and papers on performance improvements and high reliability organizations. Dr. Inozu received his master's and doctoral degrees in Naval Architecture and Marine Engineering from the prestigious University of Michigan at Ann Arbor. He's a project management professional and a Lean Six Sigma Master Black Belt and a Theory of Constraints Jonah. So before I hand over to Dr. Inozu, I wanted to also remind all our viewers that this webinar is in a listen-only mode. So if you have any questions or comments, please submit them via the chat box in Slido. The link for that, which has probably already been provided to you in the email invite. Questions will be answered by the speaker at the end of the presentation. So now let me hand over to Dr. Inozu to make his presentation. Dr. Inozu, please.
Thank you, Rajneesh. Hello, everybody. It's a great pleasure to talk again at IMarE. I had the pleasure to give a talk at the headquarters of IMarE in London long time ago. And today we are gonna talk about high reliability organizations and how you could use AI technologies to become highly reliable so that you can manage your risks much more dynamically. So we will talk about the background a little bit, then highlight some key principles of HRO, and then how we could use technology along with expert help to speed up transformations to HROs, and then we'll give some examples from the maritime industry. And some of the key concepts are detailed in our book on high reliability for a highly unreliable world. And I am also looking forward to hearing your questions as well. So we set aside time for Q&A, but do we need to become highly reliable? So this is a statistic I got from the latest Alliance report, and they talk about over 26,000 shipping incidents over the past decade. And when we look at the investigations about these, we saw that many of these could have been preventable, if not all. We see telltale signs as these weak links in the systems and protections we have in place. And if we were to intervene in a timely manner, these could have been avoided. During the 2011-2020 period, like the 10 years, 876 vessels are lost. And I looked at the statistics from Marshall Islands registry alone, and in 2020, they have reported 726 very serious marine casualties, marine incidents and occurrences. So is there a solution to this? And the answer is yes. High reliability organizations have achieved very long periods of operation without any injuries or adverse events, despite the fact that they operate in a very, very high-risk environment. And this methodology has been first developed in naval aviation and then embraced by nuclear, civil aviation, defense, firefighting, and then recently in the healthcare industry in the US, where they refer to HRO as the gold standard for safety. So what do they do differently? Well, when Admiral Lurser was in charge of CVN 70, he invited some researchers from UC Berkeley to find out whether there is anything else he could do to make his ship safer. And when the researchers looked at his practices, they found some remarkable results of what they are already doing. When they looked at various strategies and tactics they deployed and looked at the safety record, they saw a great improvement. They saw a very special style of leadership, and they saw these chief officers have the authority that crosses all lines of the command, and they could stop anything when they feel like it is too risky. And they developed this approach based on many, many lessons learned. And there were no small incidents. Every single incident was getting a lot of attention to figure out what that incident revealed in terms of vulnerability in the system. And then the principles of HRO were codified by Wyke and Sutcliffe when they were at the University of Michigan. And they came up with 5 principles. The first 3 are about anticipating a failure and acting in a very agile manner to prevent failure from happening, to stay out of trouble. And number 1 that I really like is preoccupation with failure. You always look for signs of anomalies, abnormalities, and you keep thinking about how things could fail, even if they have not. The next one that I really like is called sensitivity to operations. Because events are continuously changing, you need to be sensitive to changes in the situation and performance of these in the immediate vicinity and act as fast as possible. We also have another principle called reluctance to simplify. So when we look at uncertainty, we now realize it is always more complex than it first appears. Now, once the trouble starts, then we switch. We call this basically going from structured, the unstructured world. And then now we are trying to contain the damage. So there is this commitment to resilience. That means no matter what happens, one must survive by constantly reevaluating and sense-making until you contain the events. The picture I have here is from the movie of Apollo 13. If you remember, there was an explosion of an oxygen tank, and then the astronauts had to figure out how they could limit the leakage of the oxygen so that they could come back to Earth safely. And they had to work, of course, very closely with the ground station. And you may remember the movie, Houston, we have a problem. And the Houston team communicated and they managed to bring them back safe. The last one is known as the deference to expertise. So people also realize that some of those around them may have a better understanding of the situation because they may be closer to the event, or they may have spatial knowledge related to the operation and situation. When things are changing really, really rapidly, you trust their judgment with incomplete information to get out of trouble. So these are the 5 key principles. Now, how could you put this to practice? So is the key question, right? So there are a number of HRO values that we've detailed in our book. And these are basically about forming a team in a way that we really pay attention to dignity, giving value to everybody's job. This is the dignity. This means we are acknowledging the value of everybody's contribution. Honesty is about when somebody says something, it is indeed representing the circumstances. They are honestly sharing. And the next one is about humility. The unexpected can happen to any of us. We can all fail. The 4th one is the empathy. And since high reliability organizations work in really tough situations where people are going to fail, and it could be any of us doing the failing. So we acknowledge that. And then the 5th value is duty. We will not let others down. We have a duty to our larger community. And then finally, the perseverance or resilience is about getting through this together. We'll become smarter, stronger, and more cohesive. Now, I found out that cohesiveness is something that is actually measured in sports teams. And when we started looking at high performers, they told us, look, our team is like a family. We love each other, we care about each other. And once your team is very cohesive, you become much more safe. And when you look at where HROs were embraced and became very successful, one of the first, if not the first area, is the nuclear submarines. If you are familiar with the environment in the submarines, they have a very, very close team spirit in those submarines, and everybody keeps looking at for small signs of abnormalities, and they work very closely to manage those emerging risks. So with those in mind, we said, well, how could this be applied in the maritime shipping, in the commercial shipping? And we did see it is embraced by some offshore platforms first, and then some very high performing shipping companies started embracing it. But it starts with this reporting of these anomalies, near misses, and unsafe conditions and unsafe acts in a way that really tells the story of what happened. However, if you look at the industry, there are a lot of barriers for good near-miss reporting with good, rich content to understand how the incident evolved. What are the root causes? What are the contributing factors? And this is an excerpt from a near-miss standard developed in the US by ASTM with the support of Maritime Administration and Ship Operations Cooperative Program. And when they looked at why we are not getting good near-miss reports, they came up with a list. And one of these things is, it is very time consuming to come up with a good description. You need to do the investigation, you need to do the understanding, plus you have to have the technology to capture the details in a user-friendly manner. I mean, many ships are still using some forms, and if we had a chance to look at over 140,000 near-miss reports, and quite a few of them have very little detail, one or two liners, and they usually don't answer even the first why. Why did this happen? To go and understand the evolution. So we recently conducted a survey on behalf of the Ship Operations Cooperative Program to look at the current practices and which technologies are being used. There is the use of apps for near-miss data collection in other industries is very common now. We have seen some apps in the marketplace. Some of them are very advanced, but what we found out is many companies find the technology available not meeting their needs, so they went ahead and even developed their own apps, especially small boat operators, brown water operators are able to use these smartphones as opposed to oceanic blue ocean operators that have more restrictions about using that kind of technology. So we then try to understand what can we do to better collect the data in the first place, because unless you capture the details in a way that they are comfortable sharing it. So one of the barriers is about fearing reprimand, discipline. So when we took a closer look at it, why we don't have good data? Because we compare the near-miss reports from aviation versus maritime, and the level of detail was much more different in the maritime industry. In aviation, in civil aviation, they have a separate section where detail the human factors that led to the incident. The ones that we looked at, we found only a few incidents where even the human factor is even mentioned. So we said, well, we really need to be able to collect the data with the sufficient detail right the first time with minimal effort, because mariners on board the ships have a lot of pressure on their time. So on one hand, they need to manage their time well. That means they have little time for detailed incident investigation and reporting. But on the other hand, they do understand and appreciate that these near misses are free lessons learned. And if we understand what caused it, we can prevent these accidents. And in order to prevent these accidents, you do need to collect some detailed incident information and even have pictures and even videos and so forth. So we had a conflict. How could we deal with this so that when you see something, say something, do something, but also you capture it so lessons learned can be communicated within your organization, also outside as well. So we try to figure out, well, which kind of new technology is available all the way from the beginning. So big data and AI applications in the maritime industry, these are really exploding really fast right now. A lot of organizations are going through digital transformation, which creates new business models, new revenue streams. In the meantime, AI is now used for predictive analysis, which is where we are focused on, identifying emerging risks, seeing the trends, conducting root cause analysis, saving lives as a result, and protecting the environment. And the other piece is this IMarEST data to look at the trajectory reconstructions. And then the other area is the energy efficiency. And in order to utilize these though, you need to have good data. And you need to have good connectivity, which is a big problem for ocean-going ships. And then you need to have the computational capacity and machine learning algorithms to process that data. So first and foremost, for those of you who are not very familiar about this AI terminology, couple definitions. So when we talk about artificial intelligence, it really covers quite a few concepts and methodologies. It's an umbrella term. And it's basically computers mimicking human intelligence using logic, right? So machine learning is known as a subset of AI, where we are using statistical techniques for computers to learn from the data to do certain tasks. And then there is another subset of machine learning where we do have these algorithms that could process vast amounts of data using various neural networks. So speech recognition is one of them. So we saw a small tugboat operator. They invested in a small app where they are recording. It is voice activated recording of the near miss, where they can rapidly record what they just saw. So the next thing is the differences between supervised and unsupervised techniques. So usually when we have machine learning, we ask 5 types of questions. Which kind of a classification we have? Do we have any relationships? How much, how many? This is the regression analysis, supervised version. And then we have this clustering option, the segments. Is there an abnormality? Is something we are really interested in. And then is there anything similar? That's the unsupervised parts. And then when we process the data, we start seeing some pictures that were not available before when we were doing just statistical analysis. So the one on the right, for example, is the processing of some text-based unstructured data, which showed us a number of clusters related to certain types of activities or end results. Like mooring is one area that we are studying right now. It's one of the most frequent forms of modes of operation where we see a lot of injuries and near misses. And then we have looked at whether these could be utilized in the maritime industry. We wrote an article for the full issue of the Coast Guard's proceedings, and you could get this article from the Coast Guard site or our website, but we compared what is available in the maritime industry with the data we have versus what aviation has and the opportunities for aviation, because aviation has been implementing HRO principles for a long time. And they had a remarkable record of 0 fatalities for 10 years in a row in civil aviation in the US. Then there was one accident. But 10 years, 0 fatalities was unthinkable in the past. So then we said, okay, let's take a closer look at it and see how we can utilize the existing data while also looking into the front end to make sure you get the good data in the first place. So if you are just processing existing data in various forms and in various databases, that is a very expensive and time-consuming endeavor, but a lot of companies are doing it because there is still a lot of signal available there, but you need to clean that data. There is a big data wrangling pre-processing step. Then you can do the classification and build the database. And if you are looking at numerical, categorical data, you could use your data analytics tools. For unstructured data, we are able to see a lot of clusters using natural language processing or NLP, but all of these also require expert opinion to synthesize various views, various graphics we are getting. We are not able to take the human beings out of the picture yet in full, but we are able to minimize the demands on expert opinion to synthesize. Then we said, well, what can we do to make things better? Because at the end of the day, when operators are reporting an incident, sometimes they don't really have the technical knowledge to communicate what kinds of things may have resulted in that failure, because in many cases, they do not even have the recording. They may see some leakage of oil somewhere, or they may see some broken chain. They can speculate, but they usually do not know. And then as a result, when we look at these descriptions, we don't really have enough signal, and they don't really understand what caused it. And sometimes they may not know what to do. As a result, these corrective and preventive actions, or CAPAs as they are known, may be ineffective because they didn't quite understand what happened. And then as a result, you may have an accident again. Whereas if you are able to guide the data collection process and make sure inaccurate, insufficient, bad data doesn't go into the system, then you can really eliminate very costly data wrangling and cleaning process downstream. And then if you can automate the analysis as much as possible, you'll still need the experts, but automation of the analysis is very possible. And then of course, dissemination of the actionable intelligence in a timely manner. One organization we talked with, they said, well, it takes us 4 years to communicate the lessons learned from a near miss. So that's a very, very long time. So if you are able to achieve this new way of doing it, we could become highly reliable much faster, because we looked at how long did it take some organizations to become HROs. Sometimes it took 10 years. A lot of training, a lot of coaching goes into becoming a highly reliable organization. With this approach, we are already seeing in our applications, you could become very highly reliable and learning organization. So what we are focused on is at the front end, smart data acquisition, and then processing of structured and unstructured data, augmented by expert review to understand the trends, and then prioritize actions based on emerging threats. And then monitor this effectiveness of your solution. A lot of companies are measuring their CAPA effectiveness, but it is much faster, much more effective if we are able to do this with the help of technology, so that fleet operators can predict and act on preventable incidents. So that does start though with ensuring quality data entry. If this doesn't happen at the beginning, it is a very, very lengthy, difficult process. Right now, we are working with multiple clients, and the amount of effort that goes into addressing inconsistencies, duplicate data, errors in the data. And if you are working with multilingual crews, which is very common in the shipping industry, we have a lot of misspellings. And then sometimes you have bilingual entries. The good news is the new AI algorithms, like one of our algorithms, can utilize 62 languages simultaneously, but still you need to do a lot of cleaning at the beginning. I had no idea how many different ways you can misspell captain alone. So with that, I would like to set aside time to get your questions, but if you are interested in learning more about the algorithms we developed and our applications, and see some custom evaluation of your system, we'll share this with you as well, but that's my number. That's the US number, so you will need to put 1 in front of it, or that's the email, and I'm on WhatsApp and Skype. So with that, why don't I turn off the slides, or do I need to keep this slide on, Rajneesh? Did I turn these slides off?
So I think just leave the slide up for now.
All right,
Let's wait
great.
for the questions to come in.
Well, one thing I wanted to share is we now have some clients that are showing some remarkable long periods of time with 0 injuries. I'm looking at hard data right now where I am, and I see some ships that operated without an injury for over 3 years. And when I was talking about this 3 years ago, quite a few operators said, no, that's not possible. Well, the good news is it is now possible. But this is also seen as a competitive advantage. And what is achieved in aviation is also achievable in the shipping industry as well. Some companies already started sharing these publicly, but this usually is seen as a competitive advantage. But I was very pleased to see now, but it doesn't happen immediately. You really need to have a very good safety culture in your organization. And quite a few companies now have these learning teams now where the crews are comfortably sharing what happened and which kind of changes, additional capacities would make them safer. They gave them that level of comfort. And I am happy to see that evolution happening really fast. And AI is actually giving us a great opportunity to speed up those transformations. So do we have any questions coming in, Rajneesh?
Dr. Inozu, yeah, I'd like to start off with a couple of questions here. So basically, you mentioned that data quality is extremely important here, and we all agree. So what are some quick steps that shipping companies and shipping operators can take to ensure that the data quality is good? I mean, you mentioned even things like spelling mistakes and things that are not entered. How can a shipping company actually ensure and enforce? Are there any kind of simple steps that they can take, quick wins, which they could apply right away across their organization?
That is a great question, and a great question with no easy answers. Long time ago, I did a research project when I was at University of New Orleans, and we looked at data quality then. And one of the things people were doing, well, why don't we use drop-down menus so they don't misspell things? You could do that to a certain extent, but in one system that I saw at the time, they had a drop-down list with, I am not kidding, I counted this. They had 300 options plus another one called the other option. When you have that many options, guess which option was chosen? The other option. So the fact of the matter is, yes, the drop-down menu is one of them. It is really at the point of entry, and we looked at various products in the marketplace. In many cases, before the data is uploaded into the system, usually captains or chief engineers review the entry. They can do the first screening to make sure there is no misspelling, first of all. But you could also have these kinds of checks, mistakes proofings in the software itself. But if they could spend the time and do a quick check before they upload into the system. So the screening is done in many cases still manually. But if they are using drop-downs, and quite a few systems have drop-downs, that is the first step. But a lot of organizations now have data stewards. They even had data quality councils 20 years ago. because companies now realize data itself is a big asset. Good data is very valuable. So making sure you collect good data, maintain it, keep it up to date. I mean, data you collect today may be accurate, like somebody's address. 2 months later, somebody moves. That data is no longer valid, right? So you have to have the resources to keep it up to date. So that is the front end piece. And yes, there is technology, but it's not perfect. And you do need to have multiple layers of screening at the beginning, because if you can prevent those bad data going in versus cleaning downstream, we had a rule called 110-100 in the process improvement world. If you catch an error when the ship is in the sea trial stage, it's going to cost you $100 to fix, versus if you catch that error early in the production process, it is significantly cheaper. So the earlier you can screen and catch and fix those, the better. But basically what we are seeing, though, if you can address those at the beginning with some incentives, it is possible to get very good data, because based on our experience so far, we are seeing that shipping companies could become highly reliable in about 2 years with a focused effort and a modest investment to adopt the key principles that we have outlined here. And these organizations could really start achieving significant performance benefits even in 6 months. I mean, we are working with a company, and we did this during COVID. We looked at their processes and all the issues they had in their flow and the lack of detail. And they did training of their crews. Some of them, they did it all online. And some of them were shoreside between their tours. Some of them, they did it online while the ship was underway. They were more brief, but we are now seeing the impact. The quality went up significantly. We also looked at the time spans. I am very happy to see that every passing month, I see that time frame, the timeline is getting shorter and shorter and shorter. They are able to process much faster, but it did take a lot of time and effort and convincing and communicating the benefits and giving them the level of comfort. That was a long answer.
Yeah, thanks for that, Dr. Inozu. I have another question here. I think early on in the slide pack, you mentioned something about one of the HRO concepts was that there was no small incident. So, so basically, we understand the concept that no incident is small, but there's also a concept called as the, kind of a balance between the trivial many and the vital few, right? So you put your energy, because every organization has limited energy and resources, right? So you put your efforts on investigating and looking at the more high potential ones. So how do you kind of reconcile that, the concept of no small incident?
Right. So the hypo term we keep hearing a lot. And of course, people would like to see the high potential ones. However, and we also see that quite a few organizations do record unsafe conditions and acts or hazard recognitions, and they just don't have the resources, they say, to process them. However, if you are an HRO, you see those little unsafe acts and conditions as having a potential of something much bigger. And we actually saw cases of that. So the answer to those is to use technology to really understand what happened. But even if it is an unsafe act or an anomaly, you do not ignore it. So that's one thing. So when one of our earliest engagements started because of that, they said, well, we are capturing all this unsafe act condition information, but we just don't have time to process it. Can you use your algorithms to process these so that we know at least some of the weak links that we are capturing? We know this is a weak link. We just didn't have time. So yes, hypo is very common. That's the traditional way, but we can definitely benefit from what appears to be not hypo, but could become hypo incidents as well. So that's a mind shift that is going to be enabled by AI, and we are already seeing that.
All right. Okay. No, that's a good point. The other question that we have from the audience is basically about the HRO 5 principles, which you mentioned.
Yeah.
One of them was reluctance to simplify, and you know that's basically again a little bit counterintuitive, because simplification in anything is always better, right? I mean, you simplify a procedure, you make it easy for the crew. As you said, multi-language crew, you know, with various levels of training and background capabilities and things like that. Keeping things simple, as they say in Marine, keep it simple for sailors, right? You know, just simple. KISS principle. So why would HROs want to go towards complexity and reluctance to simplify? I would actually say make it simple, simpler. So can you throw a little bit?
Yes, so that's a very, very good point, because I came from a school of theory of constraints or constraints management, where the inventor of theory of constraints talked about inherent simplicity. He said that even very complex systems have inherent simplicity in them. However, if you look at the dynamics in various organizations, depending on the level of complexity, sometimes these simple cause and effect relationships do not apply. I don't know how many people are familiar with Kinefin network, Kinefin framework, but depending on the complexity of the system, these simple cause and effect relationships, like 5 whys and you get to the bottom of the root cause, do not actually apply. And if anybody is interested in learning more about that framework, I can share more details, but especially in our environment, with the level of interactions we have, the maritime systems are by no means falling into what they call the simple category. So understanding the dynamics is critical when it comes to very high risk operations. But maybe we can do a separate webinar just on that.
I think that'll be very useful.
Kinefin network, right. When I have friends in aviation, civil aviation, actually, they are doing a lot of work in that domain. And it's a fascinating understanding of the complexity, because we have so many interdependencies. So when we try to figure out what happened, you cannot just put 5 boxes back to back. And now in modern analysis, you try to understand the interactions and multiple flows to figure out what contributed to what, to figure out what happened. So the bad news is we have more and more complex systems, and now we are going all the way to autonomous vessels and so forth. That brings even more complexity. So unfortunately, that is something we need to deal with, but technology again helps us.
Okay, yeah, thanks for that, Dr. Inozu. We have one more question, and this is basically about similar services and other tools and techniques that are available out there. So one of them, I don't know if you heard of this, it's called HiLo. I think it is sponsored by.
Oh yes, I'm very familiar with HiLo.
And a few of quite a few operators are actually utilizing that. So just wanted to ask you, what are the similarities and differences between what you do and what is done with HiLo, which I think stands for high impact, low probability events. So how is it different? Have you kind of benchmarked or compared yourself to that?
Well, yeah, I
you
had the pleasure of visiting HiLo headquarters and met with the managers as well as the founders. And I have also been exposed to some of their work, and they're doing great work. And with the support of some major players, they are indeed making big contributions. I am not fully aware of their applications of AI yet, and I'm not at liberty to talk about some of the things. We do have an NDA with them, so I guess I'm not able to tell you the details of it, but yes, they are doing great work, and whenever we can collaborate with HiLo and other organizations, we can. But in our case, our main focus is on the front end, making sure we collect the data in a guided manner, which captures the details, and then the processing with very advanced tools we have. So I'm not aware of the details of their algorithms. Their algorithm is not in the public domain yet, but we are communicating. I know they are collaborating with a number of great prestigious universities in the UK, but I don't know the details of some of their prediction algorithms. We have ours.
Great. Okay, thanks, Dr. Inozu. So we got a few other questions coming in. I'll just present them as they come in. So one of them is, in your empirical experience, is there a particular root cause analysis methodology which you found most effective? And this is in particular with respect to HF. I believe that means high frequency incidents.
Yes. So very good question. One methodology we saw that is very popular is Taproot, which has been developed based on human performance based issues. Then it has grown into multiple industries, but none of the methodologies we saw, and I don't want to name them here, but the root cause analysis itself is an evolving science, I guess, is the right term, and I'm following various approaches there. Quite a few organizations are using just simple 5 whys, but now, for example, I know one organization is using a methodology which is developed from the constraints management world, what is called current reality tree. So it basically helps you understand the interdependencies and the evolution. But this is, again, could be a webinar by itself. But Taproot is the one that I am seeing more and more applied. But let's have another webinar on that.
Yeah, no, absolutely. Thanks for that. Thanks for that insight, Dr. Inozu.
Yes.
We've got another question from one of our members. And the question is, what can ship charterers do to improve safety culture and bring HRO concepts to operators, including themselves? So ship charterers, actually like companies that charter other operators, third-party technical managers, things like that. What could they do?
So some of the organizations we know have assured their mariners that they won't be punished. When we looked at how aviation became highly reliable, and they actually have a database called Aviation, it's called ASRS, Aviation Safety Reporting System. When the incident is reported, at the beginning, who reported the incident is known. It is reviewed by multiple experts, and in many cases, they go back to the person who reported it to gather more details, because in most cases, I think the number I heard from the offshore world, at least half of the time they have to go back to get more details. Then they delete who provided that information. And we, as part of our SOCP survey, we also have had sessions with Nautical Institute that operates the Mars database, as well as CHIRP in the UK. They do the same. After the learnings are captured, who reported it becomes, they basically delete that information. Now, quite a few systems have an option. When crews are reporting, and a lot of shipping companies give the option of, you can give your name or you can communicate anonymously. As long as they feel they won't be punished, they are very happy to share their experiences. But even with the high-end organizations, I just learned even this week that some mariners still feel super uncomfortable to put their name and identify. So anonymous reporting is one way of doing it, but I'm not sure whether I'm just answering your question. So as the charter, are you empowered to give that kind of immunity? I mean, if it is, if it is not done on purpose, and very few people do it, it did happen, but nobody wants to make an error, right? So you just need to give them the level of comfort to share. We do know some shipping companies give the anonymous reporting option, but sometimes you can easily find out who did the reporting. So you just need to give them that level of comfort. I mean, in one organization, we saw the safety department knows who reported it, but the CEO does not. They came up with a procedure that only the safety department is reviewing the data, learning from it, but top-level management gave the green light that they don't want to learn. In fact, I also do a lot of work in healthcare. In one government healthcare organization, they are specifically requesting that whoever reported it should not be captured. So it is, when they do their analysis, and it's a very lengthy 17-step root cause analysis process that I saw, but who did the reporting is not considered. So it is not important who did it, it is the process itself, understanding the process itself, not the who question is eliminated, is in the process, even public domain. If anybody wants to see it, I can share it. So you need to know what happened. What is more important than who is what I'm trying to communicate.
Okay.
So I need to get more.
Absolutely. And Dr. Inozu, also with respect to the earlier question, in terms of what is, which is a good root cause analysis methodology, the HF referred to, human factors. So, so basically, does that make a difference there? I mean, like, would you recommend?
Yeah, I mean, when we look at the data, 80% plus of the accidents can be linked to human factors, fatigue and so forth. And now these big organizations, just I think TMSA just came up with a requirement to start reporting human factors in these incidents. So that is something that is really, really lacking. I mean, with the exception of few shipping companies, I mean, some of them even told us, even if you know that's human factors related, we don't want to officially write in our reports because they feel like this is going to bring some kind of a liability. That's a huge culture change. And of course, some protections are needed there, I guess, too. But human factors play a really, really big role. I mean, fatigue. I mean, we are looking for one client, for example, we are even looking at how much rest time they had before coming on board between two tours. Because at the end of the day, every one of these things could have been avoided if you had situational awareness. I mean, they do a lot of things for situational awareness. They go through the risks and so forth, but sometimes you are tired or you didn't sleep well or you are thinking about something happening at home. So the situational awareness is it's really based on human condition. So that is something that will be super important to capture, but we need to have the protections in place so people are able to capture that critical detail.
All right,
I
Dr.
came up with a guide, but when I ask people, they seem to be concerned about documenting them at the moment in many organizations is what we are seeing.
Okay, so we are coming close to our scheduled time. So I'll take this opportunity to thank you, Dr. Inozu, for a very fascinating and informative presentation. We greatly appreciate your time and effort in preparing for this and making this presentation. And we also
can I just have one final statement then before closing? So the key point is that most maritime companies, shipping companies that we have observed, they are really not reporting and collecting the data with sufficient quality to really accurately determine or understand the true root cause of an incident, regardless of the root cause analysis methodology you are using. So getting good quality data with sufficient detail is critical. So thanks again. Sorry, I just wanted to make sure I communicated that.
Yeah, sure.
Yes.
We would also like to thank all our global viewers who were able to join us for this webinar and for their comments and questions. Also, a big thanks to all those people behind the scenes who make this webinar possible.
Yes.
Now, anyone needing further information on Sharp Focus, please contact Dr. Inozu directly. His name and telephone number and details are there on the screen right now. Now, before I close, I would also like to mention that the IMarEST does offer CPD, which is continuing professional development credits, to our viewers and members attending these webinars. So if you did register and attend this webinar, a CPD certificate will be sent to you via email. We look forward to having you, our members and other non-members, join us for future presentations coming up soon. So do have a great rest of the day. And with that, we conclude today's webinar. Thank you all.
Great. Thank you.
Thank you.